Good evening, students. How are you? This is Ankit Joshi. I welcome you all on India's largest e-learning platform, BYJU'S Exam Prep. Students, are you able to hear me? Hello. I just need response from your side. Am I audible or not? Is everything all fine regarding the audio and the video? Deepu Patnala, welcome to the session. So let's start. So students, in this Parmanu series for Signals and System, we are focusing the questions appeared in Signals and the questions which are relevant from Signals and System, important in BARC upcoming exam. So students, this is the brief introduction about me. I have been teaching in GATE and ESE domain since many years, and my subjects of interest are engineering maths, Signals and System, and analog circuits. So meanwhile, I can see few more faces. Those who are here, they can just respond. Is everything all fine regarding the audio and the video? Ensure hitting the like button. I request all of you to share the link in all your contacts. A small announcement for you, students, we are also starting GATE 2024 fundamental series for EC, electrical, instrumentation and computer science branches. So students, that series is starting from 1st of March, that is today itself. So don't forget to join this series and get the advantage of this to enhance your preparation for GATE 2024. One very big announcement: free workshop how to ace GATE 2024 with college or job, and this workshop will be conducted by Richa Gupta ma'am, and that will be going to held on 2nd of March, that is tomorrow 7:30 p.m. Don't forget. And yes, this workshop will be on our app. Students, here comes our first question. I can see few comments. Pinky, Tuhin, Deepu, all of you welcome to the session. So students, we will just revise some very important questions and concepts. Find the energy in the signal. So we have given a signal x of t, which is sin 80 upon pi t. So students, for this signal x of t, the Fourier transform is nothing but x of omega. We can calculate the energy either by using time domain signal or by using Fourier transform part. Okay, so this energy of this signal can be calculated either by x of t or by x of omega. But if you observe this x of t, this is sinc function or sampling function related to sinc function. So for this type of function, integration becomes difficult. So what we are going to do, we are going to find its Fourier transform. So Fourier transform of sin 80 upon pi t, this will be rect of omega upon twice a. So if you wish to plot the spectrum, this is your omega axis. On the y-axis, we are plotting x of omega. So this will be a spectrum. This will be a rectangular pulse from minus a to plus a, having constant amplitude 1. This will be a rectangular pulse from minus a to plus a, having constant amplitude 1. Comfortable, students? So now we wish to find out the energy using this spectrum. So by Parseval's energy theorem, are you aware of Parseval's energy theorem? By Parseval's energy theorem, if you calculate energy using the spectrum, it is 1 upon 2 pi integration from minus infinity to infinity modulus of x of omega square d omega. This is the format to calculate energy. Can I have your response? So 1 by 2 pi. The valid range of integration we have is from minus a to plus a, and x of omega is 1. Its modulus will also be 1. and its square will also be 1. Okay, sir. So ultimately it is 1 by 2 pi. Integration of 1 is omega. Lower limit minus a, upper limit plus a. So student, it is a minus of minus a. So twice a upon twice pi. So ultimately the energy of this signal x of t will be a upon pi. And yes, what is the energy for the signals? What is the unit for the energy? That is joules. A by pi joules should be my answer. Okay, so with the help of this particular question, we just revised our concept regarding Fourier transform of rectant sink, regarding Parseval's energy theorem, and yes, of course, what is energy of aperiodic signals. You can have a screenshot of this, and students, you can collect the PDF of this particular session from my Telegram group, Electronics by Ankit Joshi. Electronics by Ankit Joshi. You can collect the PDF. Now see this question. Now, this particular question seems to be a question from mathematics, but if you are well aware of the Fourier transform theory, then this can be easily targeted. This can be easily approached using the concept of Fourier transform. So all my dear students, I can give you a recap that if we are having a both-sided exponential signal, this is called as tent signal. इसे कहते हैं tent signal, e raised to minus a mod of t. So its Fourier transform is twice a upon a square plus omega square. Okay, now if I am going to put the value of a as 2, then this will be e raised to minus 2 mod of t upon, not upon, on the right hand side, that is on the other side. After taking Fourier transform, we will be getting twice a, that will be 4, twice square, that will be again 4, plus omega square. Understood this one? I'll just hide myself so that you would be able to see the entire screen. Yeah. So students, I hope you are all following. So student, this is my x of omega and this one is x of t. Comfortable? Now, if you apply Parseval's theorem, then energy of this signal will be 1 by 2 pi minus infinity to plus infinity x of omega modulus square d omega. Very nice. So 1 by 2 pi minus infinity to infinity. What is x of omega? This is x of omega. Its square will be 4 square, that is 16 upon 4 plus omega square whole square d omega. Correct? Okay, sir. So we have got this integration. Now ultimately, if you divide it by 2, then 16 by 2 will be 8. 16 by 2 will be 8. Denominator is 4 plus omega square whole square d omega, and pi is remaining on this side. So pi times e will be the answer. Pi times e will be the answer. Now the question arises to my mind, what is E? So E is nothing but the energy of this tent signal. Okay, sir. So energy of this tent signal will be 1 upon A. If it is e raised to minus at, then the energy of this tent signal will be 1 by A. So pi 1 by A. And what is A here? A is nothing but 2. So pi by 2 joules should be the answer for this integration. Pi by 2. Comfortable, students? Can I have your response? I'll just give you an opportunity to take the screenshot of this. I'll just hide myself. Now Tuhin is asking why A is equal to 2. It's quite simple. I want to generate this integration. So I want to generate this function, and in this function I am having 4. So 4 is nothing but 2 square, and that's why I have selected A is equal to 2. Got it? Respond कीजिए भाई. The concept of autocorrelation function. So students, great. So autocorrelation function. Now Pinky is asking how pi by 2. Hey bacha, see, this is pi times E, and energy of this trend signal is 1 by A, fixed values formula. So 1 by 2, 1 by A, so A is 2, so pi by 2 will be the answer. Now find the autocorrelation function of x of t. Autocorrelation function of x of t. Autocorrelation function of x of t. This is nothing but r of tau. Okay, and this will be x of tau convolution with x of minus tau. Okay, sir. So all my dear students, this can also be written as Fourier inverse of their Fourier transform of omega multiplied by x of minus omega. This is in accordance with the convolution theorem. So Fourier inverse x of omega. What is the Fourier transform of this function? It is 1 upon 3 plus j omega. And what will be the Fourier transform of? It's in what we say, the time reversal. If it is if t is replaced by minus t, then omega will be replaced by minus omega. Right. So ultimately, this Fourier inverse of 1 upon a plus b, a minus b, a square plus omega square. Correct? Okay. So Fourier inverse of this function is, if you adjust by some constants, you can generate a formula here. So that constant is twice a upon a square plus omega square. So I have multiplied by 6, so I have to divide by 6 also. So Fourier inverse of twice a upon a square plus omega square will be e raised to minus a mod of tau. This is the autocorrelation function for this function e raised to minus 3t u of t. Comfortable? I need your responses. Now see this one. For the signal x of t shown in figure, we need to find out capital X of 0 and this integration. So first understand, x of t is having Fourier transform x of omega. Very nice. Now students, we know one formula. What is that formula? X of omega is integration from minus infinity to infinity x of t e raised to minus j omega t. Now if you put omega equal to 0 both sides, अगर आप दोनों तरफ omega equal to 0 रखेंगे, then what you are going to get? So you will be getting capital X of 0, and this is minus infinity to infinity x of t. Now please see here, e raised to minus j omega t. Omega कितना है? What is this omega? Omega is 0, so e raised to 0 is 1. And this integration is nothing but area under x of t. So can you calculate the area under this diagram? Can you calculate the area under this signal x of t? So area under this signal x of t, what I will do? I will simply complete this rectangle and will calculate the area of this rectangle, and then I will subtract this triangle's area from the area of rectangle. Area of rectangle minus area of this triangle. That will be easier approach for us. Say yes. Area of rectangle, length into breadth. So 4 is this dimension and 2 is the height. Minus area of triangle is half base. This base is 2 units and this height is 1 unit. This height is 1. This is the height of triangle. This is the base. So 2 is the base and height is 1. So 8 minus 1 will be 7. So answer for x of 0 is 7. This is my first answer. Now what we have to find out, this second part. this second part. This second part is obtained using another property. See here. By inverse Fourier transform formula, x of t is 1 by 2 pi minus infinity to infinity x of omega e raised to plus j omega t d omega. Now this, in this integration or in this expression, I am putting t equal to 0. If you put t equal to 0, you will get x of 0 1 by 2 pi minus infinity to infinity x of omega e raised to 0 is 1 and t. Can you tell me what is this integration? E raised to, sorry, minus infinity to infinity x of omega d omega, and this is 2 pi x of. Okay, sir. So 2 pi is constant and x, small x of 0 is the value of the signal at t equal to 0. Value of this signal at t equal to 0 is 2. कितना value is इसका? 2 है ना? We are getting the answer is 4 pi. So 4 pi is the answer for the second part. चलिए respond कीजिए फटाफट. Students, are you enjoying this session? Ensure hitting the like button. Don't forget. Next. Now student, just go through this question. Consider a Fourier transform pair y of t and y of omega. Y of t is the time domain signal. And its Fourier transform is, हाँ भाई तो x of 0 का वैल्यू 2 है. Y of t, thank you Deepu. Y of t Fourier transform is y of omega. Now see here, if y of t is advanced in time domain, then what happens? It means, please concentrate, please. See, if y of t is having Fourier transform y of omega, then you can shift this signal y of t in two ways. Either you can delay it or advance it. Delay means t is replaced by t minus a. Then what will be its Fourier transform? It is e raised to minus j a omega into y of omega. And in case of advancing, it will become y of t plus a. And after taking Fourier transform, it is e raised to plus j a omega into y of omega. We are going to use this particular statement. Now see here, what they are asking, if the signal y of t is advanced in time domain, then what happens? See here, this particular function has got two parts. Magnitude part, so magnitude part will be same. See, magnitude part is y of omega and e raised to j theta omega. For this, magnitude part is same, y of omega, but in the original phase, this a omega will be added. Are you comfortable? So magnitude part remains same. See, magnitude part remains same. Magnitude part remains same. But what happens? There is a change in the phase part. What is the change? Earlier the phase was theta omega. Now the phase is changed to theta omega plus a omega. It means a linear phase term is added. So whenever you are doing a shifting in time domain, it corresponds to yes, phase modulation, you can say, or phase change in frequency domain. So phase is changed. The original phase is added with a linear phase term a omega. So amplitude spectrum remains unchanged. Only phase spectrum will change. So in my opinion, yes, option C will be the correct. Now tell me, what is the scene? Understood everyone? Let's proceed. Ravi Teja, how are you, beta? Okay. So if f of t and f of omega forms Fourier transform pair, okay, and if f of t is an odd symmetric signal, then what is f of omega? Very, very nice question. So students, f of omega is the Fourier transform of f of t. So it will be integration from minus infinity to infinity. Your function f of t will be here, and e raised to minus j omega t will be here. And we all know that this e raised to minus j omega t can be written as cos omega t minus j sin omega t. Now here I am splitting this into two parts. मैं यहाँ पर इसे दो parts में break कर रहा हूँ. I am just splitting this into two parts. First part is minus infinity to infinity f of t cos omega t dt. Second part is minus j minus infinity to infinity of t sin omega t dt. Now see here. Already it is given that f of t is odd symmetric. Odd. F of t is odd. So this one is odd. And this one is even. Cosine function is even function. So odd into even will result in an odd function. The result is an odd function. So this overall is an odd function. So if you are integrating an odd function from minus infinity to infinity, the result will be 0. Now see this part. F of t is odd. Sine function is also odd function. Odd into odd, this result will be an even function. So this is an even function. The integrand in the second part is even function. This one is an even function. क्या है? Even function. So you can just multiply by 2 outside. Outside you can multiply by 2 and you can make this integration only right sided. 0 to infinity. Instead of minus infinity to infinity, you can write 0 to infinity. And now you can tell me which one is the correct answer. Minus j2 0 to infinity, yes, f of t sin omega t. Option C is the correct answer. Basic maths is involved over here. Got it? Next. Yes, come on. So student, this one is again a very, very important question. Now see, starting from x of t, first we have to generate the steps for this function. 2 times x of minus 3t plus 6. Okay. 2 times x of minus 3t plus 6. We have to generate this one. All my dear students, we will start with x of t. Now, Deepu, odd into even is odd function, beta. advance it by 6, time advance it by 6, so it will become x of t plus. Now time scale it by a factor of 3, this will become x of 3t plus 6. Time scaling, in time scaling you have to just replace t by at, here a is 3. Now time fold it, so time fold means just replace t by minus t, and this 2 means amplitude scaling. Venkat, what happened beta? I have no updates regarding that. So amplitude scaling by factor of 2, 2 times x of minus 3t plus 6. Now students, we will take its Fourier transform now in each step. Now please concentrate. See, Fourier transform of x of t. Fourier transform of x of t is x of omega. When it is advanced by 6, you need to multiply x of omega by complex exponential term e raised to j 6 omega. Time scaling by factor of 3. So it is 1 upon 3 x of omega by 3. So in this function, wherever you have omega, omega will be replaced by omega by 3. 6 omega by 3, this will be 2 omega. And x of omega by, very nice. Then what? Venkat, I will ask Rakesh sir to update on the Telegram groups. Now, after time folding, where t is replaced by minus t, omega is replaced by minus omega. T raised to minus j2 omega, x of minus omega by 3. Now, amplitude scaling, just you need to multiply by 2 both sides. 2 by 3, e raised to minus j2 omega, x of minus omega by 3. Now, if you further wish to write this function in terms of f, what you have to do? In this argument, just replace omega by f. And outside this argument, wherever you have omega, that omega will be replaced by 2 pi f. So 2 omega will become 4 pi f. So just have a screenshot of this. We'll check which option is correct. 2 by 3 e raised to minus j 4 pi f. 2 by 3 e raised to minus 4 pi f x of minus f by 3. I believe option C is the correct. Option C is the correct. Comfortable, students? Yes, Venkat. Whenever this function x is an arbitrary function, we just replace omega by f. But if this is a known function, sine, cos, rect, sinc, in that case you need to replace argument by 2 pi f. But if it is an unknown function, arbitrary function, just replace omega by f. Yes, come on, respond fast. I'll just hide myself, you just go through it once. So Venkat, have you got the correct concept now? Confident enough to do the correct? Now see this. And students, BARC exam dates are out. Yeah. So I may announce, I will just share you the dates as well here. Yeah. If the Nyquist rate of the signal x of t is 500 Hertz, then the Nyquist rate of the signal x of 5t. Very nice question. See here. What happens? First and second April. Very nice. If you are having a signal x of t, its Fourier transform is x of omega. And if you are scaling this x of t by a factor of 5, then what happens to this Fourier transform? It will be 1 by 5 x of omega by 5. So what happens to this spectrum? This spectrum is expanded by a factor of 5. So maximum frequency will also be the 5 times of the given maximum frequency. So Nyquist rate is 500 Hertz. It means new Nyquist rate will be 5 times 500 Hertz. Five into 500 Hertz, that is 2500 Hertz, means 2.5 kilohertz. Can I have a response? 2.5 kilohertz means option B is the correct answer. Now, the frequency response of a system is given. Okay. H of omega is given as 1 upon j omega plus 1, and we want group delay and phase delay. So I will just tell you how to approach such questions. H of omega is 1 upon j omega plus 1. Very good. So students, this can be written as magnitude of h of omega and phase part of h of omega. Magnitude of h of omega. I'll just get back to your doubt. Already Nyquist rate is given, beta. I'll just get back to your question. Wait. Okay, I'll just revise the first question. See, if the Nyquist rate of a signal is 500 Hertz, so already this Nyquist rate was given. Now, if this signal is scaled in time domain by a factor of 5, what happens to its spectrum? Its spectrum will also be will be expanded by 5 times. Okay, so if the spectrum is expanded by 5 times, it means maximum frequency will be the 5 times of the original frequency. So Nyquist rate will also be 5 times. Okay, yeah. Venkatraman, time period, this particular term is relevant for periodic signal. This is not the case of periodic signal. Now see this. H of omega. H of omega is, okay, H of omega magnitude is 1 upon under root omega square plus 1 or 1 plus omega. Now what about theta omega? Theta omega, see. How to calculate the phase angle? See, it is present in denominator. Complex part is present in denominator. So minus tan inverse omega. Very nice. So students, phase delay TP, phase delay TP, phase delay TP is minus theta omega upon omega. Minus theta omega upon omega. Very good. So minus of minus plus tan inverse omega upon omega. So this is phase delay. Not exactly, Venkatraman. You are missing the basics. You are missing the basics. So TP is tan inverse omega upon omega. Now moving towards the group delay. So group delay is calculated by using a different formula. Group delay is Tg. It is minus d by d omega theta omega. Very nice. So minus d by d omega. What is theta omega? Theta omega is this one, minus tan inverse omega. So minus minus plus d by d omega of tan inverse omega is 1 upon 1 plus omega square. So we have got the expression for group delay, we have got the expression for phase delay. What we are expecting first? पहले क्या चाहिए? Group delay. So what is group delay? Group delay is 1 upon 1 plus omega square. Okay. And what is phase delay? Tan inverse omega upon omega. So option B is the accurate answer. Venkatraman, when we say x of t, that signal is not defined for t equal to 100. That is defined for the entire domain of t. I don't think so, Tipu. If you are putting a particular value of time, it means you are just observing the signal at that instance. Now, this is a question from Laplace Transform. A continuous time LTI system is described by this differential equation. Okay. They have given you x of t as this one. X of t. Okay. Now, please concentrate in this question. Assuming zero initial conditions, the response of the above system is given by. Okay, very nice question. So, students, yes, Venkat, Pinky, Deepu, Green, everyone should concentrate. In this particular question, we will first write the given differential equation in the form of dashes. Just like double derivative, y double dash, first derivative, y dash. Okay, so y double dash plus 4y dash t plus 3y of t. Now see this one. 2 times d by dt x of t is x dash t. 4x of t as it is. Now what to do? Now we are going to take Laplace transform both sides. Laplace of y double dash t. When initial conditions are all set to 0, it is simply y s square y of s. Then 4 times Laplace of y dash t will be s y of s. Laplace of y of t is simply y of s. Laplace of x dash t s x of s. Laplace of x of t is simply x of s. Now what to do? We will be just taking y of s common. So s square plus 4s plus 3, y of s common. On the right hand side, we can take 2 and x of s common. Very nice. Now student, what is this y of s? 2 plus 2 upon. What are the factors of s square plus 4s plus 3? s plus 1 and s plus 3. Very nice. And what is x of s? X of s is the Laplace of this function. It is 1 upon s plus 2. So all my dear students, we can strike out this s plus 2 from the numerator and denominator, and we are finally getting y of s as 2 upon s plus 1 s plus 3. Now you can do the partial fractions. Partial fraction कर लेंगे 1 upon s plus 1 minus 1 upon s plus 3. If you solve this, what you are getting? S minus s cancelled, शहीद हो गए. 3 minus 1 2. So this, both of these terms are exactly same. Taking inverse Laplace transform. So Laplace inverse of 1 upon s plus 1 is e raised to minus t of t minus 1 upon s plus 3. Its Laplace is e raised to minus 3t u of t. Ultimately it is e raised to minus t. If nothing is mentioned, we have to consider right-sided part only. We have to assume the signal to be right-sided. So e raised to minus t minus e raised to minus 3t, e raised to minus t minus e raised to minus 3t, u of t, option B is the correct answer. You are seeing plus, we are having a minus sign over here. Come on, respond here. Next. See this question. Let's go through this. Okay, previous question. Go through it. All fine? Any doubts? Let me know. Chalo. Moving to the next. See this. A system is described by this differential equation. So first of all, we'll write this differential equation in the form of dashes. So y double dash t plus 5y dash t plus 6y of t equal to x of t. Now what to do? Okay, we will just, okay, what about the initial conditions? Y of 0 is 0 and dy by dt is also 0. Okay, all initial conditions are again set to 0. So students, what you need to do, you need to just take Laplace transform both sides. दोनों तरफ Laplace लीजिए. Laplace of y double dash t will be only s square y of s when initial conditions are all set to 0. Laplace of y dash t will be s y of s and 6 times y of s. X of t Laplace is x of s. Now if you take y of s, sorry, yeah, y of s common, so s square plus 5s plus 6, y of s common equal to x of s. Now I will work on to calculate x of s. What is this x of s? X of t. X of t is 1 in the interval 0 to 2. In the interval 0 to 2, x of t is 1, means it is a rectangular pulse. So for this, okay, we will just express this rectangular pulse in the form of unit step signal. Students, always remember, whenever you wish to take Laplace transform, okay, whenever you wish to take Laplace transform of rectangular pulses, express those rectangular pulses in the form of unit step signal. And whenever you have to deal with the Fourier transform of these rectangular pulses, express this rectangular pulses in the form of rect function. Okay, rect function when you need Fourier transform, step function when you need Laplace transform. So here we are dealing in Laplace transform, and that's why we will be considering them in unit step signal. So u of t minus u of t minus 2. Now taking its Laplace transform, this is x of t, so its Laplace will be x of s. What about its of s Laplace? U of t Laplace is 1 by s. It is e raised to minus 2s by s. Ultimately 1 minus e minus 2s by s. So this is x of s. We are going to use this in the next frame. So y of s, x of s upon s square plus 5s plus 6. What are the factors? S plus 2 plus 3. Yes. What is x of s? X of s क्या है? X of s is 1 minus e raised to minus 2s by s. Now check the options. We need to find Laplace transform of y of t. Laplace transform of y of t means y of s. So 1 minus e raised to minus 2s, s plus 2, s plus 3. Is it? Check it. Check कर लो. 1 minus e raised to minus 2s, 1 minus e raised to minus 2s, s plus 2, s plus 3. Yes, absolutely correct. I need your response. I need your response on this. Shall I proceed? Yeah. Now see this. Solve the following equation. Okay, we have this equation, and here solving means we have to find out y of t. That's it. So just take the Laplace transform both sides. दोनों तरफ Laplace ले लो. So students, okay, before that I just want to tell you that this is y of t, and this one is y of t convolution with x of t. And this is x of t plus delta t. Now taking Laplace transform both sides. So Laplace of y of t is simply y of s. Laplace of y of t convolution with x of t will be y of s into x of s. Laplace of x of t is x of s. Laplace of delta t is 1. So I am taking y of s common. So the remaining part is 1 plus x of s. You have pointed out, have you pointed out that the Laplace of delta t is 1? Yes. So 1 plus x of s on the right hand side. You can cancel these two brackets. Ultimately you are having y of s equal to 1. So inverse Laplace of 1 will be delta t. This is my answer. Inverse Laplace transform of 1 is delta t. Remember this, Laplace transform of delta t is 1. So inverse Laplace of 1 will be delta t. See this question. Now, this is a periodic signal. Venkat, concentrate here. So this waveform is repeated after a duration of 6 units. So we can say that here the period is 6. Period is 6. So we want the average value. Average value means the DC component. So the DC component is denoted by A naught, and it is 1 upon t area under 1 period, area under x of t in 1 period. Okay, area under x of t in 1 period. So t is 6, so 1 by 6 is already out. Now what is the area? What is the area of this? So here you have one right triangle, okay, then one rectangle, and then one more rectangle. So this is first shape, this is second figure, this is third figure. So what is the area of the first figure? Half base into height. Base is 2 unit, height is 1 unit. Half base into. Now what is the area of the second figure? It is a rectangle. Base is 1 unit, height is also 1 unit. Area of the third figure, base is 1 unit, height is 3 unit. See here, 2 and 2 gets cancelled, so this is 1 plus 1 plus 3. 5 by 6. So 5 by 6 will be the DC component. 5 by 6 will be the DC component. Now see here. A periodic rectangular signal x of t as shown in the waveform. Frequency of the fifth harmonic of the spectrum. Very nice question. So student, first find out its time period. So we can see here that it is started from this positive pulse, then negative pulse, and then again positive pulse. We can say that the period is 4 units. Period kitna hai iska? 4. But what is this scale? Millisecond. So period is 4 millisecond. Period kitna hai? 4 millisecond. So what is fundamental frequency? It is the reciprocal of the period. 1 by 4 millisecond. 1 by 4 milli means 1000 by 4 hertz. It means the fundamental frequency is 250 hertz. And what we want the frequency of the fifth harmonic. So frequency of the fifth harmonic is 5 times the fundamental frequency. So 5 times 250 hertz. So it is 1250 hertz. 1250 hertz. Option D will be the correct answer. Next. Okay, this question may have more than one correct answer. Okay, because this question is just to revise the concepts. Students, in the first part, 0 to 15 is the interval of integration of t, delta t plus 5 d. Okay. Now student, what is the position of the impulse? Impulse kahan par located है? This impulse is located at t equal to -5. So is this impulse present in this range of integration? The position of the impulse is at -5. Is this impulse present in this interval? No. So the answer for this integration will be 0, a big 0. Okay, so the value of a is 0. So in option A, they are saying that the value of a is x of -5. Conceptually, they are correct, but it is wrong because the answer should be 0 in this. So option A went wrong. Understood, bacha? Now see this, delta 2t plus 6. Delta 2t plus 6 is 1 by 2 delta t plus 6. Remember. Now I am going to utilize this in the second part. What is the second part? Y of 2t plus 4. multiplied, not convolution, it is multiplications. In second case, it is multiplication, delta 2t plus 6. So, बच्चा लोग, y of 2t plus 4 and this delta 2t plus 6, how much it is? 1 by 2 delta t plus 3. 1 by 2 delta. Whenever two functions multiplied, out of them one is impulse. So in your final answer, impulse will be always there. And the adjacent function should be evaluated at the position of the impulse. The adjacent function is y of 2t plus 3. It should be evaluated at the position of the impulse, that is t equal to minus 3. Okay? Yes, sir. 1 by 2. When you put t equal to minus 3, it is 2 into minus 3, minus 6, minus 6, minus 6 plus 3. Minus 6 plus 3 is minus 3. Delta t plus. Just check. This should be the value of the second part, and second part is nothing but b. So this is the value of b. 1 by 2 means 0.5. Y of 1 by 2, y of minus 3. Is it? So it's also wrong. Okay, it is delta 2t plus 4, na? Delta 2t plus 8. Position of the impulse is t by 2, that is 3. It. Option B is also wrong, right? Now, the third case. 2t plus 4. 2t plus 4. Okay. I got it. I made a mistake here. 2t plus 4 here. Okay. 2t plus 4. यहाँ पे just a printing mistake. So minus 6 plus 4. Minus 6 plus 4 is minus 2. And now I can say my option B is correct. Yes, Ashish bhai, correct bhai. Y of minus 2 delta t plus 3. So option B is the correct one. Comfortable? Now moving to the third part. X of t plus 2 convolution with. Okay, so 1 by 2 is already out. X of t plus 2 convolution as it is, and this is delta t plus 3. Now what is the answer for this? X of t convolution with delta t is simply x of t, but with the net shifting. So 2 plus 3, that will be 1 by 2 x of t plus 5. Option D is the correct. Bolo bhai, understood everyone? See this question. We have a signal y of t. Let us calculate its energy first. इससे पहले इसका energy calculate. So student always remember few formulae. If you are having a rectangular pulse whose width is t and height is a, let us say, okay, then its energy will be a square t. If you are having a rectangular pulse whose height is a and width is t, then its energy will be a square t. If you are having a symmetrical triangle whose width is t and height is a, then the energy in this case will be a square t by 3. if you are having a right angle triangle whose width is t by 2 and height is a, in that case energy will be a square t by 6. Okay, this right angle triangle can be inclined on the left or right, whatever. Okay, so we can see that if we have two such right triangles, then its energy will be a square t by 6 and a square t by 6, that is a square t by 3. That is the energy of this symmetrical triangle. Okay, so what is the energy for this rectangular pulse? The energy for this rectangular pulse is simply a square t. A is the height, height is 5 and t is nothing but 6. So this is 150 joules. And energy for figure 1 and figure 2, if you combine these two right triangles, you will get a symmetrical triangle. So their energy is E2, and that will be a square t by 3. A is 5, t is nothing but t is the width, so the width then will be 2 plus 2, that will be 4 upon 3. So 100 by 3 joules. So the total energy for this signal y of t will be 150 joules plus 100 by 3 joules. So this is कितना होगा भाई? 450 plus 100, 550 by 3, 550 by 3. Yes, it will be 183.33 joules. Option A is the correct one. So energy of the signal y of t is 150 joules. That will be wrong. And I am also calculating the energy for 2 times y of t by 3. So students, concentrate, huh? Y of t, very good. Time scale it by factor of 1 by 3, you will get y of t by 3. Then what? Then you can do amplitude scaling by factor of 2, you will get 2 times y of t by 3. Very good. Very good. Very good. Now, what about their energy? Energy for y of t will be E. Whenever you are doing time scaling by factor of A, whenever you are doing time, I request all of you to hit the like button. Students, are you following? Are you enjoying? You may observe the process to be a slower one, but definitely this will give you a chance to ball out. So student, whenever you are doing a time scaling by factor of A, energy will become E by A. So the new energy will be E upon 1 by 3. E upon 1 by 3 will be 3 times E. Okay, sir. And whenever you are doing amplitude scaling by factor of A, the previous result will get multiplied by A square. So here A is 2, 2 square. So 2 square is 4, 4 3s are 12 E. Okay, sir. And what is this E? 550 upon 3. So 4 into 550, that will be 2200 joules. 2200 joules will be the answer. This one is also the correct one. So energy of 3 times y of t by 2 plus 3. Let us check the correctness of this one. See here, y of t, I want this signal, so advancing by 3. Now time scale by factor of 1 by 2, t will become simply t by 2, and then amplitude scale by factor of 3, 3 times y of t by 2 plus 3. Energy of y of t is E. Either you delay or advance the signal, energy will not change, will remain E only. Then time scaling by factor of A, energy will become E by A. So E upon 1 by 2 will be 2E, and amplitude is by scale of amplitude by a factor of 3. This will be 3 square into previous result. So 9 2s are 18 E. And what is this E? 550 upon 3 joules. 6 into 550 will be 3300 joules. Got it? Just have a look over this. Next. Now consider the following statements. When we learn deterministic and random signals, we have certain important points regarding them. So deterministic signals are predictable. Deterministic means one which can be determined, that is, they are predictable. What is being written here? Deterministic signals can't be predicted, so this one is a wrong statement. Random signals can be expressed. Arey bhai, random signals cannot be expressed in the form of mathematical expression. Can be expressed, this one is also wrong. Random signals can be analyzed using probability and statistics, that is correct. So one which is random, that can be analyzed using the probability theory. Okay. So only S3 is the true one. Options. Now students, the Fourier transform of a function is equal to its two-sided Laplace transform evaluated. Just go through. This is Laplace transform and this is Fourier transform. So in Laplace transform, when you put s equal to j omega, you will get Fourier transform. Laplace transform evaluated for s equal to j omega will give you Fourier transform. But this is true only for absolutely integrable signals. For all type of signals, this relation will not hold. This relation will hold only for absolutely integrable signals. Absolutely integrable signals means those signals whose Laplace transforms ROC covers j omega x. Okay. So on the real axis of S-plane, no. On a line parallel to the real axis, no. On the imaginary axis of S-plane. What is this imaginary axis? Imaginary axis is j omega axis. Okay. So students, option C is the correct one. Laplace transform will be equal to Fourier transform and S will be equal to j omega. And when S is equal to j omega means we are talking about the imaginary axis. Which one of the following is the correct? So student, this is simply the expression for time scaling property. So Fourier transform of f of a t, it is 1 upon a f of omega by a. Option D is the correct. Next. If the Fourier transform of x of t is 2 by omega sine pi omega, then what is the Fourier transform of this one? So in the original Fourier transform, that omega will be replaced by omega minus 5. So 2 upon new Fourier transform. 2 upon omega will become 2 upon omega minus 5 and sine pi omega, sine pi omega will be replaced by omega minus. Option D is the correct one. Done? Go through this. For delta, okay, match the following. List 1 function in time domain and list 2 Fourier transform. So delta t Fourier transform is 1. 1 is nothing but constant. So for A is mapped with 3. Gate function means rectangular pulse. For rectangular function, we have sinc or sampling function. So B is mapped with 4. Gaussian function will have Gaussian Fourier transform. So normalized Gaussian function will have Gaussian function Fourier transform. Is mapped with sinusoidal function. If you are having sine or cos, then its Fourier transform will have impulse. Impulse means delta. ABCD 3421. ABCD 3421. Option B is the correct. Next. This is pure mathematics. Omega square plus 21. 21 is splitted into two parts, 9 plus 12. And then you can separate. So omega square plus 9 upon omega square plus 9 is 1. And 12 upon omega square plus 9. Now see, g of omega. 1 plus. 12 can be written as 2 into 6. And 6 can be written as 2 into 3. 9 can be written as 3 square and then omega square. Now Fourier inverse. So Fourier inverse of g of omega. Fourier inverse of 1 is nothing but delta t. 2 as it is. And Fourier inverse of this function 2a upon a square plus omega square, it is e raised to minus a mod of t. Oh, this is nothing but your g of t. Your answer. This should be your answer. Students, ensure hitting the like button. Stay tuned and just comment, make your presence in the comment box. Have you all hit the like button till now? If you have not done so, do it right now. Just winning. Nice. Let's go through the question once. Come on. Please see it. A signal x of t, it is 100 cos 24 pi 10 cube t. So what is the maximum frequency present in this signal, you know? Just you need to divide this by 2 pi. So when you divide this by 2 pi, you will get 12 into 10 raised to 3, 12 kilohertz. This is f max. Okay, is ideally sampled with a sampling period of 50 microseconds. Sampling duration is 50 microseconds. So sampling frequency will be 1 upon ts. So 1 by 50 micro. 1 by 50 micro means 10 raised to 6 upon 50. Very nice. 100 by 50 is 2 and 10 raised to 4, that is 20. Comfortable? 10 raised to 6 is very simple. 10 raised to 20 kilo. So we have got fs also, sampling frequency. After getting the value of fs, now see, you are having a sampler, you are allowing a signal x of t whose maximum frequency is 12 kilohertz. Here you are having a sampler whose sampling frequency is 20 kilohertz. At the output of the sampler, you will get NFS plus minus FM, all these frequency components, which are then passed through a low pass filter. Low pass filter will be characterized by cutoff frequency. So cutoff frequency of that low pass filter is given as 15 kilohertz. So all those components which are less than or equal to 15 kilohertz will be available at the output. So we just observe here. Okay, so fs is 20 n plus minus fm is nothing but 12, and these are all in kilohertz. When you put n equal to 0, avoid negative frequencies. When you put n equal to 0, you will get 12 kilohertz. When you put n equal to 1, so 20 plus 12 will be 32, which is beyond this 15 kilowatts. And 20 minus 12 will be 8 kilowatts. Very nice. When you put n equal to minus 1, it will be minus 32, or you will get minus 8. Avoid this. Put n equal to 2, so 40 minus 12, 40, 28 kilowatts, and 40 plus 12 will be beyond this. No need to put other higher frequencies. So all those frequencies which are less than or equal to 15 kilowatts will be our answer. 12 kilowatts and 8 kilowatts. Option D is the correct answer. Yes, Tejaswini. Super. Perfect. Shabash. Thank you to him. Thanks a lot. So here comes the next question, maybe the last one. The spectrum of a band limited signal after sampling is shown in the figure. Okay. After sampling it is given, it means this central frequency is nothing but fs. Okay, sir. See, the second replica is about fs. Next replica is about twice fs. Okay. So this is fs. So fs is the midpoint of 150 and 350. Fs is the midpoint of 150 and 350. It means it is 250. Are you following? Are you following? Fs. So Fs is 250 Hertz. Ts will be reciprocal of Fs, that is 1 upon 250. So this will be 1 divided by 2. This one is 4 milliseconds. Option C is the correct answer. Comfortable, everyone? So student, that's all from my side in this session. Thanks for coming. Love you all. Take care. Stay happy. Stay safe. Do subscribe this channel for further such type of sessions. Jai Hind. Jai Bharat. Students, you can download the PDF from my Telegram group, Electronics by Ankit Joshi.